Observe a flawless commercial kitchen operating at peak efficiency. The equipment is state-of-the-art, the surfaces are immaculate, and the line moves with total precision. But inside the walk-in cooler, an uncalibrated thermometer reads exactly 1 degree out of the safe temperature zone. During an official inspection, this single degree triggers a critical violation. The standard managerial reaction is writing up the line cook for forgetting to check the gauge, treating the failure as an isolated mistake. In a rigorous food safety management system, human error is never a valid root cause. It is a symptom. A failed audit indicates that the overarching administrative control system failed to manage its most volatile variable, the human operator. Public health regulatory frameworks view personnel management as a rigid prerequisite program, not a soft skill. The human operator is categorized directly alongside the facility's mechanical and chemical systems. They are managed by the same logic. Similar to a commercial oven, a human operator requires a documented baseline calibration before safely processing food, followed by continuous performance monitoring during their shift. To maintain order, food establishments must utilize a 3-part administrative architecture: input calibration, the verification loop, and corrective and preventative action, known as CAPA. Biological safety inside a facility is only guaranteed when human unpredictability is successfully engineered out of the daily process. The first pillar is input calibration. This is the process of certifying an operator before they ever touch the food system. It begins with a strict physiological baseline. Staff must hold valid medical commission certificates and adhere to absolute illness reporting protocols to prevent introducing biological hazards into the environment. Next is the educational baseline. All food handlers must pass the WFEEC exam, which proves they understand how foodborne pathogens multiply within the temperature danger zone. These disparate physiological and educational requirements are aggregated into a single, verifiable administrative tool, like a centralized certification tracker. Failing to maintain this centralized tracking log is a systemic regulatory failure, even if every employee on the floor happens to be technically certified. Allowing an uncalibrated human onto the PLEP line is operationally identical to cooking with an uncalibrated, broken oven. The second pillar is the verification loop. While food handlers execute physical tasks, the system's integrity hinges entirely on one specific role. This relies on shared accountability, which separates the physical execution of a task from the ultimate operational liability for that task. We can see this hierarchical liability in the exact regulatory definitions. This table outlines the responsibilities for the person in charge, or PIC. The PIC must monitor the facility, implement hygiene requirements, and provide documented evidence that the safety system is running. This establishes the cardinal rule of administrative auditing. A blank space on a compliance log is an automatic failure. If the verification is missing, the task never happened. At the end of every operational shift, the PIC must physically review the equipment, check the sanitation schedules, and sign their name to the daily logs. The PIC signature is the exact mechanism that translates temporary, floor-level cleanliness into permanent, legal regulatory compliance. This leads to the third pillar, CAPA. What must management do when the verification loop catches a failure? Take a real-world inspector's note. Food staff failed to register for or pass the mandatory Ministry of Public Health Safety exam. To solve this, we use the 5 whys methodology of root cause analysis to dig past the immediate symptom. The excuse that staff simply forgot is rejected. Drilling down reveals the root cause. The facility lacked an onboarding protocol. Corrective action fixes this immediately by registering uncertified staff. Preventive action secures the system long-term by embedding exam registration into the new hire checklist. Root cause analysis exposes and repairs the dangerous gaps in managerial oversight, rather than blaming the individuals involved. This framework applies to physical failures. Imagine a cook approaching a hand-washing sink during service, only to find the dispenser completely dry. The resulting inspection notes would flag a severe compliance breach: the absence of antibacterial soap, missing hand sanitizer, and an empty tissue container. A manager might simply refill the soap and reprimand the cook, but this only addresses the symptom. Applying the CAPA framework reveals the true root cause. The daily morning routine lacked a standard operating procedure mandating a physical stock check of all hygiene stations before opening. The required verification method dictates that the duty manager must now conduct unannounced audits of those sinks at midday and physically sign off on the replenished checklist. True food safety is achieved by repairing the managerial routine that allowed the sink to go empty in the first place. Combining these three individual pillars reveals the complete architecture of a functioning food safety management system. Information flows continuously between these nodes to eliminate blind spots. A failure caught by the verification loop feeds directly into CAPA, which then immediately updates the input calibration training for the next shift to fortify the entire structure. This data-driven loop removes subjectivity, emotion, and blame from high-stakes personnel management. When this loop functions correctly, the restaurant becomes a self-correcting organism that is inherently immune to individual human errors. Return to the paradox. Why do facilities with perfect technology still fail critical health audits? These failures occur because management trusted their human operators to be perfect, instead of trusting a rigorous system to verify them. The heavily tabbed compliance binder on the manager's desk is the physical evidence of systemic control. You cannot eliminate human error through willpower or by pointing fingers. True food safety is achieved by engineering administrative controls that catch the error on paper long before it ever reaches the plate.